Hello, this is video 4, and I'm living Groundhog Day. This is actually the third start of video 4, but it's worth it. We finally get around to some new stuff, for crying out loud. Oh wait, not even that. We're still doing S-list. Still S-list. And I'm going to call this variation, at least it's a little different, variation of print debug. Which hardly seems worth the trouble. Debug is not officially sanctioned function of S-list anyway. It's not part of our abstract data type list of operations. It's there just to help us see stuff. So we can mess this up, I suppose, if we want to, and nobody's really going to care because it's not officially supposed to be used in a final version of an application. That was a lot to say with no content whatsoever. So here's my variation. I'm going to start way back over here. Void print debug, print stuff to the screen. It doesn't return anything. It's got to be a member of S-list. Colon, colon. S-list, colon, colon. Function name. This one's going to be, I'm going to call it the lazy version. It's actually not going to do a whole lot of work. Print, as if the other one did. Print, runs in the family, I guess. Print lazy debug. How can we possibly be lazier than that one little for loop? We don't pass anything in. It's examining the current state of the object without changing it. It's just printing out stuff to the screen, so it can't move the cursor, can't change the head or tail or anything. So it is an accessor, and it does have to have const for that reason. There we are. Print lazy debug, void const. How lazy is it? Well, it's actually not going to do any work on its own at all. It calls another function, print lazy debug, and we'll pass in the address not of the head node but of the first real node in the list, the one that has data in it that we actually want to print to the screen. So it will pass in head arrow next semicolon. That's it, one line function. And yes, I can hear you screaming through your phone. Please calm down. I know. These two have exactly the same name. Surprise. C++ allows that. You can have 2, 3, 4, 5, 6, 7, 8, as many functions as you want with identically the same name as long as they have different parameter lists. The compiler figures out which version of print lazy debug I'm calling by looking to see what parameters I pass in. If I call print lazy debug from the main program with empty parentheses, it knows I'm talking about this one. I'm going to have another version. I'm going to have to write out another function called print lazy debug that accepts one parameter. If I had one with 2 parameters, it would figure that out separately as well. That's called overloading. Sounds like a Star Trek term. Captain, the reactors are overloading. That was the worst Scotty impression in the history of cyberspace. Okay, we've overloaded print lazy debug. This one accepts a parameter, that one doesn't. What else is there to say about it? Well, I've got to have this function. So even though this one, that's going to be the one called by the main program, not pass anything in, print lazy debug, empty parentheses, it's going to make this one its cousin that's accepting a single parameter do all the work. And I've got to make that a member function as well. Void S-list colon colon. I don't know why I'm so tempted to misspell S-list. Maybe I'm subconsciously rebelling against all this. Print lazy debug. Let's see. Let's reverse engineer. If they're passing in head arrow next, what kind of a thing is that? What kind of parameter is this expecting? You're exactly right. Surprising I can hear you so well through your phones and computers, huh? This is accepting a node pointer. And just to keep it easy to spell, I'm going to call the variable name P. I think I can spell P. Print lazy debug node P, and here's the rules. You remember this. If this is an accessor, it can only call other accessors. So this also has to be an accessor, or it's a compiler error. Accessors cannot call mutators. Dims the rules. Well, you know what? Before I go any further, I'm going to erase this. And before I even finish out this function, I'm going to put a couple of comments here that I'll talk about later. This is like mental notes for the me of the future, a few minutes into this video. This is a public, P-U-B-L-I-C, wrapper, W-R-A-P-P-E-R. That's actually what it's called. Sounds ludicrous, I know. But this is called a public wrapper function. This is called a private overload. Now, I'm going to write a little more stuff, and then I'm going to talk about what those blue comments actually mean. So you actually have something to look forward to in this video. Let's see here. Let's visualize this. I don't want to have to draw that picture again. Please don't make me. We've already got a linked list. It's got an empty head node pointer. It's got an empty head node, a pointer to that at the head pointer, cursor, tail, yada, yada, yada. What is this doing? This is saying, okay, print lazy debug is still going to print out the contents of the list. There's no point in printing out the garbage in the empty head node for crying out loud. So this is passing in the address of the first real node in the list. Everybody with me there? It's that L shape. It's passing in head arrow next the address of the node with Darby in it, or whatever the first real node in the list is, because that's the first thing we've got to print out. This version, this print lazy debug, let's clear our minds of this one. This is a completely separate function. It does get a parameter. It gets a pointer to a node. Unless, the list is empty. If the list is empty, then head arrow next is 0. And if we try to print out the data that's stored at 0, crash and burn. We don't want that. Remember that little, not trick, but the little suggestion. Should have been a strong recommendation, but I'll say it was a little suggestion. If there's no work to do in the function, let's get out of here. So if there's no work to do, how do we detect that? If P, the head arrow next to just got passed in, if that's equal to 0, double equals. If it's exactly equal to 0, our work is done. There's nothing to print out. No output. Return. Close curly bracket. Remember that? If there's any way possible whatsoever that the function is not going to be able to do its job, if it can't print out anything, if it's going to fail, then detect that, get out of here immediately. That's about to become excruciatingly important. So hold that thought. If P0 return, well, what if it's not 0? Here's another thing. All these things that you've got to remember from CS2. If we didn't return, that means P is not 0, and by convention, we assume that P has a valid value that does in fact point to a node. See how these conventions become so important? We're not going to allow garbage pointers. So if it's not 0, we assume that in fact it does point to a node and there is data to print out. And I don't even have to put an else. This is an implicit else. If I'm not gone, if I'm still here, then that means that condition was false. And I don't have to put an else because if it's a special case of how you can construct an if-else in a function. It's called an implicit else. If I'm still here, it's the else. So C out, less than, and let's finally, mercifully, for crying out loud, print out the data that we're here for. P arrow next, I don't think so. P arrow data. And in case there's more to print out after it, I'm going to put a blank after it like that. But I'll keep it on the same line. So if there's a bunch of data, it'll all be on one line instead of a ridiculously long column. That's kind of irrelevant. That's kind of a semicolon. There. So if P was 0, we're gone. If P's not 0, we'll assume it's valid and we'll print out the data that's there. And now we need to start a loop or something and go through this over and over and print out everything else that's in the list. Maybe there's 100 things in the list. You know what? This one got me so lazy. This one didn't want to do any work. This one's from the same family. Bad influence. It don't want to do any work either. So it's going to make somebody else do all the work. Oh, I'm exhausted. I detected that that was a real node. I printed out its data. Now I want to go rest under a shade tree. Somebody else, why don't you take charge of it? We can always farm this out to another function And we'll do it. Print the rest of the list. Talk about lazy. Print the rest of the list. And we'll go ahead and pass in the address of the node where it should start. In this case, it'll be the second real node. This was printing out the data in the first real node, so we've got to pass in p arrow next. What we're doing, I don't know if you remember this sort of real-time code construction convention construct, but you go ahead and call functions even if they don't exist yet, assuming that the you of the future will be bright enough to actually write that function. And I'm taking heavy advantage of that here. If p were 0, I'm gone. I printed out the data. I assume I'm smart enough to start at the second node and print the rest of the list. So you see, I got much less work for myself to do here. I don't have to worry about boundary conditions and loops and all that unless somebody else worry about that. The me of the future can worry about that when the time comes to write this function. So if that's successful, and I'll assume that it will be, if that's successful at printing the rest of the list after the first data value, then I'm done. Close curly bracket. We're done. Two separate functions. Now I wanted to go back and talk about these. I'm glad I wrote those blue comments. Mental notes don't work, but blue notes work. Public. This has to be public, otherwise it's useless. The main program has to be able to call our print debug function, otherwise we wrote it for nothing. So the main program or another class that's using linked list, whoever, they can call print lazy debug because this will be defined up in the public section of our header file for the linked list. Now then, this one has to be private. It cannot be public. Why? Well, because outside of the exclusive club of slist member functions, this is an unknown data type. Node is defined in the header type in the private section, meaning this node data type is only known to the functions inside the exclusive linked list class club. So this is like the doorway. This one opens the door, gets our foot in the door. And now that we went through the door of our public function, when this starts executing, we're actually inside that linked list object. Now it can see all of the stuff. Everybody else that's in there. Wait, it's a party with the cursor and the tail and the head node and all that stuff. So it can use any of those at once. So this really was just kind of to get our foot in the door from outside, from the main program, so that we could use the private variables and pass off the work to somebody else. Here's to somebody else. This gets all the credit. When we return to the main program, it'll be from this function. But this one's the one that's supposedly doing the heavy lifting, even though we know that it kind of copped out as well down here. But let's take a look at this. Private overload has to be private. Unknown data type outside of the linked list. It's an overload because it's got exactly the same name. Now, I didn't make up these blue comments. I would like to be able to take credit for them. If I had, then this would be England public wrapper, an England private overload. But no, alas, somebody else came up with it first. These two, that's a convention to have two functions named exactly the same thing, where one of them is the get your foot in the door public wrapper. The other one is the private version with exactly the same function name. It's an overload, meaning it's the same function name, but it's got to have a different parameter list. So it's like two companions, two cousin functions that together accomplish all the work except for this poor guy down here. Okay? Now, the one that is really buried deeply, that doesn't get any credit whatsoever, even as a public wrapper, even as a private overload. I don't know if I left space. But let's say if we can figure out, I might have to wrap around on a whiteboard. I didn't leave much space for print the rest of the list, did I? It's got to be a member function. It's got to be an accessor. So all of that kind of tells me, without much flexibility, what the first line has to be. I better back up over here. Void. Print the rest of the, it's got to be a member function, slist : Even I'm subject to the error of leaving off the slist : Yes, I do that all the time. I'm sorry. Slist : Print the rest of the list. And let's see, what else is mandated? It's accepting a single parameter of type pointer to node, node star p, and you think, no, you can't do that. P is already used as a variable name. Remember from the core image, the program image in memory, every time we call a function, it starts all over again, making up the local variables and parameters and everything. So this variable p right here is completely different memory address than this variable p right here. This is within that comfortable confine of the stack frame for the print lazy debug function. So any local variables it has, any parameters it has are local to that function, and there is no clouded namespace. In other words, there is no chance that it's accidentally going to use the wrong p variable. This one's completely separate. Okay? That's a little bit of a sidetrack, but it's still important to understand that these two variables p have nothing to do with each other. I could have changed that to q. I'm not going to accommodate that because we know better now. It's got to be an accessor const. Open curly bracket. Okay, so finally we got to roll up our sleeves and get something real done, for crying out loud. But before we do that, let's think about that. What we just now did was pass in the address of the second real node in the list. There is the possibility there is no second real node in the list, and we better check for that. If p double equals 0, then there was no second real node in the list. Open curly bracket. Let's get the heck out of here. Return, close curly bracket. What if it wasn't 0? Implicit else. We're still here. Then there is a second real node in the list. P points at it, and let's print out its data. C out, less than, P arrow data, less than, and we'll put a blank after that one as well, in case there's anything else in the list. Now, even though I left space for maybe one or two more lines, somebody has got to take responsibility for looping through and printing out all the rest of the nodes in the list. We can't put it off indefinitely. But you know what? This is like the laziest family of functions on earth. This one also is going to say, you know what? I did my job. I did it well. Somebody else can do the rest of it. So it's going to call a function passing in the address of the third real node in the list. Yikes. It's like that second Cat in the Hat book. We keep taking off a hat, and there's yet another cat in early 60s reference. You're welcome to not understand that. What have we got? We just now printed out the data, the second real node in the list. I'm going to call another function to do all the rest of the work. Print the rest of the list. The longest function name I've ever written on the board, I think. Print the rest of the list. And we'll make it start off with the third real node in the list, since this is the second one. The third real node in the list will have address p arrow next. Semicolon. And since I took that lazy cheater's shortcut there, I don't have to do a loop anyway, which is great because now I can just close off with a curly bracket. Is anyone else experiencing deja vu, Groundhog Day with these functions? Particularly, I don't know, maybe this one and this one. Take your time. I got all day. Well, actually, no, I don't. What do these have in common? Actually, quite a bit more than they have in common. Look at the logical structure here. If p is 0, return, p is 0, return. Print out the data, print out the data. Call another function to do all the rest of the work. Call another function to do all the rest of the work. Except for the stray function name here and there. These are logically identical. What does that have to do with anything? It actually has a big deal to do with a big thing. Watch this. Get out of here, you cousin that wants to take credit for all of our work when we're doing all the work ourselves. We don't need this function. We already have this function. Strike through, double strike through, triple strike through. Get ready to adjust the curly bracket. This can call itself print lazy debug. Pass in the address of the next real node in the list, p arrow next. Close curly bracket. Stick a fork in us, we are done with that. We are not done with this kind of that. Oh no. We just now broke the seal on it and now there's no going back. It's almost like when we called this function and we opened the door or the Pandora's box into the internal mystical world of the linked list. We just now opened the mystical magical door of recursion. This is a recursive call. R-E-C-U-R-S-I-V-E. Recursive call, double underline, single underline. In simple layman's terms, it's a function that calls itself. Why is that a big deal? Well, it is an incredibly big deal. All of the best sorting algorithms known to man, the most effective sorting algorithms, the fastest, most efficient, they're all recursive. Almost all operations that deal with non-trivial data structures, which we are now starting to barrel toward, those are all recursive algorithms. They all have functions that call themselves. And that might not seem to make any sense at all, but I got to tell you, once we get into it, you'll wonder how you ever got by without recursion. It becomes an essential tool in your toolbox, and there's no going back. Now, this is a mess right now, but it is important. I want to do a quick review. Public wrapper, this is visible outside the linked list class. That's the one that will be called. Instead of the old just plain old print debug, now we can call print lazy debug. It turns around and calls the private overload, the function behind the scenes, the one behind the curtain, the one that's inside the linked list class that's actually doing the work. It checks to see if someone sent it a 0 pointer, and if so, it returns. Doesn't do any work. Otherwise, it stays here, prints off the data in that node, and then calls itself, moving the pointer one notch down the line in the linked list. And it goes through again and again and again. It's sort of like a loop. Yes, it's a recursive loop. Do you remember? Now, this is getting a little ahead of the game, but it's a little bit of a teaser as well. That convention, I said, you know what, it's a good idea to test and see if there's no work to do. And if there's no work to do, get out immediately. You have to do that in a recursive function. This is like when the while loop condition finally becomes false, if we were to go back to the comfortable land of iterative programming. Iterative means it's not recursive. Iterative means you're going through a loop. Recursive means you're calling itself over and over and over again. This is the analog of that. It's a rough equivalent of that. It's sort of like a while loop, except instead of a while, it's a function calling itself over and over and over and over again. We have to test at the beginning. If we shouldn't be here, then go back. That's what ends the while loop. What if we don't? Oh no, I forgot to do that. Fine. You get infinite recursion. It keeps making stack frame after stack frame for an infinite number of function calls. It bumps into the heap. Remember those? When those bump into each other, you get crash and burn, segmentation fault. Your program is done. Can't possibly work. So that's a pretty important thing right here. I am going to do a whole nother video because this is so important. We need to trace through this and see what the hey this is doing. So for right now, get the ideas down of the terminology, recursion, private overload, public wrapper, all that other stuff, and try to hold that in your mind through the next video 5 when we trace through this. And now I'm done with this one. See you online.